So, just as important, obviously, as the policy, is to exploring the technology. And really, really excited for our next keynote panel. We've obviously seen all the headlines out there about artificial intelligence, AI, autonomy. Where's all this going? What's it mean? Kind of across sectors, obviously not just aviation. But AI is really changing everything about the way that we're living and working on a daily basis, and lots of efficiencies and enhancements, but also lots of questions. So the potential of AI to enable autonomy for commercial drone applications has been a topic for many years, but recent advances are changing the paradigm around this topic and for our whole industry in ways that few could have imagined a few years ago. So I'm really, really excited to hear our next panel of distinguished experts who is going to talk about what does this mean for you? What does this mean for your business? And ask and answer those very questions. So please join me in welcoming our distinguished Drones and AI panel to the stage.
Good morning, everyone. And thank you for being here at this year's Commercial UAV Expo. I hope you are as thrilled as I am to delve a bit deeper into the ever-evolving world of commercial drones and the technologies that propel it forward. Today we have a great panel discussion prepared for you, and the discussion will explore not just the wow factor of AI, but mainly the how factor of AI. So how we develop, deploy, and leverage these technologies in a way that maximizes benefits and minimizes the risks, and what those recent advances in AI mean for your business. So with me here today, next to me, we have Barrett Lovelace from Collins Engineers. He's VP of UAS, AI, and reality modeling. We have Travis Mason from Merlin Labs, Chief Policy and Regulatory Officer. And we have Brandon Groves, VP, Regulatory and Policy Affairs at Skydio. So welcome to our speakers today. So to kick things off and to get everyone in the room on the same page, I would like to start with a very high-level question, because we see a lot of hype around AI and all those topics, and it's really hard to grasp what this actually means. So the first question, maybe Brandon, to you: how do you define AI as such in your daily work and in the context of commercial drones?
Sure. Well, thanks, and good morning, everyone. Just to level set, right? We refer to AI as this suite of technologies that allow computers and machines to perform tasks that were previously reserved for human intelligence and human judgment. But what that means is somewhat mysterious, right? It's this strange concoction of maybe code and chips, and when it works, it really feels like magic. When you used ChatGPT for the first time, it felt pretty magical, right? Especially because you were, like many of us, probably using it to do your kid's homework, which is far and away the best use of ChatGPT, and your kid doesn't need to know. When you watch a video of a cargo aircraft flown by Merlin Labs with no pilot, that's pretty magical. When you use a small Skydio drone to build a digital twin of a bridge or a transmission tower without doing much of anything, that feels like magic. And AI really is magical, but it's also becoming real. So in the last few years, we've started to see a shift. There have been two phases in the development and deployment of AI that are relevant for our purposes today. In the first phase, AI was a tool primarily for processing information. ChatGPT is that. You call it up on your phone or your computer, and it will spit you out an answer, 8 out of 10 chance that it's correct. But we're moving into phase two. And in this phase, AI jumps off the page, off of your phone, and into the real world, primarily in the form of robotics. And in this phase, AI moves from a tool to a teammate, something that works with you and, in fact, works for you, unlike a lot of machines that definitely you work for the machine and not the other way around. AI is enabling this fundamental paradigm shift. It's It's reminiscent of the early days of computing. Anybody remember the command prompt, DOS? It was hard to make computers work for you. You really worked for the machine. What changed that? Well, these pretty pictures called Windows and Mac OS, right? The graphical user interface. That opened up the world of computers to lay people, to everybody could access computers. The computer was just as smart, but it was easier for you and I to touch. AI is for drones what Windows was for computers. It's opening up and democratizing this technology in a way that's starting to become real.
Thank you so much for this explanation. Travis, you are also developing AI to get it out into the real world. How do you see this whole, noise or hype around this topic AI? I mean, it is really hard to grasp, for people to understand what it actually means, like this black box phenomenon of an AI. Do you feel that there's a certain hype, a certain unhealthy kind of conversation going on regarding this topic, or how do you communicate to your potential clients what this technology does and what it doesn't?
Yeah, I think the vastness of this technology and the vastness of its definition is pretty beautiful. How many of you all have seen the exosphere outside of this hotel? The big sphere. It's the largest display of LEDs in the world. Well, on that display right now is an art piece by Rafik Anadol. He's a Turkish-American artist, and he has leveraged AI, machine learning, to really answer the question, if machines can think like humans, can they also hallucinate like humans? And so the art piece is called Machine Hallucinations. And it takes millions of photos from NASA, from the ISS, from the Hubble telescope. It takes millions of photos about our flora and fauna here on our planet. And it imagines new planets, new environments. It really becomes its own painter. And this artist has had to explain himself, explain his technology, explain the way his technology works as he's implemented this piece both here in Las Vegas and really around the world. He's done amazing things with machine learning and AI. And I only mention that to show kind of the expanse of AI. We're having these conversations in Hollywood. Even here in Vegas, the Culinary Association is having these conversations about how AI may change hospitality here. So this is a really big technology that's going to have a lot of broad impact. And at Maryland Labs, we're looking to build a pilot, just not a human one. And in the same way that kind of combination of algorithms and technology is painting a very beautiful piece of artwork on the exosphere, we hope to use that same technology over time to grow a pilot and to mimic the human performance and the capabilities of a pilot. And we know that sounds crazy, but aviation has done it to this date very, very well with automatic flight, with flight navigation, with even terrain warnings. These aspects have really shown how software-based technology can take over for a human. And I think the asterisk that Brendan really talked about a little bit was that as you increase automation, something happens in the flight deck, something happens on railroads, something happens in cars. You begin to put into question the workload of that operator. And so as we have this conversation about how AI is going to impact aviation, we can only have that conversation and be in a safe place in the future if we get that teaming aspect right and we think about the performance, the workload, the attention, the memory aspects that are impacted as we put new technology in the flight deck. So excited for this conversation.
Yeah, thank you so much. Barrett, you are using drones on a daily basis with your team. What kind of opportunities did the AI that you use mainly for data analytics open up for you? Like, what was the biggest impact using these kind of systems?
Yeah, and we're using AI as part of our everyday work. I know there's a lot of hype and a lot of talk about it being the future, but for us, it's right now. And I think that there's a lot of room in our industry to grow the implementation, but the technology is there now that we are using it. And we're using it in sort of two different ways. The first is for data collection. We're using things like the Skydio 3D scan to collect data using AI. And I think the barometer for us has been just that, flying a drone used to be, you'd be very nervous, flying around a bridge and under a bridge and near traffic. And it was sort of stressful, and now we're bored, and we are literally kind of impatient waiting for the drone because it's doing everything by itself. And then the second way we're using AI is for analytics. We are post-processing our data into digital twins, applying AI to find things like cracks, any kind of defects that we normally would be looking for just with our visually or with our eyes. And that has been pretty transformational for us because if you can imagine, if you're not an inspector, it's easy to imagine going out on a bridge and there's thousands of cracks, and trying to document those with pencil and paper is almost an impossible task. So AI has improved the quality, and two, we talk about how engineers don't go to school for 4 years to stand out in the field and draw cracks. Engineers should be making decisions about what we're doing with bridges or whatever type of infrastructure. So that's really what AI is enabling us to do, is to be making decisions instead of doing mundane tasks.
All right. So basically, building a digital twin helps you to track assets over time, helps you to, monitor the development or cracks and other things that are important to the structure. Do you see any, or like, what was the biggest impact on your business? Was it like time saving, or did it save a lot of costs? I mean, there's like certainly certain upfront costs to purchase drones and the software. What were like the major impact on your daily business when using that technology?
Yeah, it's a good question. So I guess the first thing is we can show cost savings, and sometimes they can be significant. It's usually when we're reducing traffic control and reducing lane closures, those kinds of things, reducing some of the heavy equipment. But also, I think the biggest thing for us is improving the quality of what we're doing. And we can do that in two ways. The first is just being able to create a digital twin. We put all of our inspection information on that digital twin. We can do some of that inspection in the office before we go in the field. And so there's a pretty huge improvement in quality that way. And then the digital twin becomes a much better way to communicate those results to the owner. So instead of having to read a 50-page written report, they can look at that digital twin and see all of the defects and see all the notes right there. So that's been a huge savings. And for us, we can hit on all those things. Safety, not having to have people working from heights or around traffic is a big safety improvement for us. But the quality thing is the biggest component. And one of the other ways we're using it is, if you can imagine, when we do quality control and engineering, we kind of want to have two independent calculations or things, but it's just cost prohibitive to do two independent field inspections. But we can create the digital twin, and we can have a quality control on that digital twin, and we can still have our field inspection. So now we have true quality control.
That sounds amazing. Brendan, from your point of view, do you see beyond the awareness of the drone in the room, where obstacles, to deconflict and to basically build its own flight path, do you see other opportunities for AI in the future as a drone manufacturer?
Yeah, it's a good question. So at Skydio, we were founded by some really nerdy people who met as graduate students at MIT, where they were studying AI and computer science. And it was there that they helped to pioneer some of the fundamental technologies that allows drones to fly themselves with the skills of an expert pilot. We principally use computer vision matched with a bunch of deep neural networks that are running on the drone in real time. So we use multiple cameras that see in every direction. We take a real-time image of the world that's actually in real time, and we run millions of computations per second against that image, such that the drone knows exactly where it is, and it can use that information to avoid obstacles and actually plan and navigate in complex situations, even without GPS or even without communications link. But once you have those ingredients in place, you have a drone that knows where it is, that knows how to navigate, and can start to make intelligent decisions, then you can layer on top of that automated workflows. And this is really the holy grail, right? So Barrett mentioned 3D scan. This is a software platform that allows you to create a digital twin of basically anything without doing much of anything. Just set your boundaries, and essentially the drone does the rest in 3 dimensions. This isn't the old school 2-dimensional flying. That is an example of workflow automation, where that's a task that you can pay people to do that. It's just exceptionally mind-numbingly boring and difficult, right? One pilot has to take sometimes thousands of pictures, minutely moving the control this way and that way. Maybe the wind blows you off. And then it can take a week or a month to reconstruct all of those images in the back end. It's really painful, really dull work. And that's why we offered 3D Scan to help automate that. There are lots of other ways that you can automate workflows, whether it's inspecting transmission towers. Maybe you know exactly what that looks like and you know how to do it. Maybe it's inspecting other parts of a power plant. That's really the next level of AI and automation that we'll see across the space. This is true not only on the data capture side with drones of all sizes, including those in the small side, but also on the analytics side, as Barrett mentioned. Really sophisticated AI-enabled tools, some of which you can see on the show floor, that are helping you save a ton of cycles internally by telling you where the cracks are, so you don't have to go out there by hand in 110-degree heat and draw them on a piece of paper anymore.
Thank you for the answer. Travis, on your homepage, it says crawl, walk, run. In which phase do you think you are right now in the development of your system to, yeah, I understood correctly, the goal is to reduce the workload of pilots in a way that perhaps, you know, double-seated cockpits are not necessary anymore. Maybe you just need one person in charge, and you have software taking off of that workload from that person. Where do you see us, or where do you see the company in the development of what you do right now, and what are the major challenges in that process?
Yeah. So just to step back a little bit, because of the definition of AI is so vast, I think it belongs in its proper box and its proper context. And so when we think about crawl, walk, fly is what we say, we think about the initial solution to get us to that future state of maybe single pilot or reduced crew scenarios. And that present state is looking at integrating our technology on smaller aircraft and working with innovators such as the U.S. military on what this technology could look like in larger aircraft. And so we're at the phase where we're really looking and exploring what this technology would look like for a very basic takeoff to touchdown autonomy with what we call an automated communication system that's a subsystem of a technology system that we're getting type certified, or supplemental type certified with the New Zealand CAA in validation with the FAA. That system includes an automated communication system that basically ingests voice or digital communication from ATC, interprets it, is parsing through that data for flight plan changes, positions the flight plan change to the pilot in command, and then is able to self-generate a voice automated response back to ATC, of course, with the pilot's approval. So that's the very basic place that we're starting. That system does leverage artificial intelligence, in particular machine learning, so that it can better recognize human voice as it ingests those communications or human messages. And that's a really important piece for us. It's an offline aspect of our system, and it's offline so that we can think ahead about how to certify that sort of technology. So the lesson in the vastness of this sort of AI buzzword is if it stays a buzzword with the regulators, you're not going to get too far. And if it stays a buzzword in your company from a technology development perspective, you're also not going to get so far. So we're really thinking about how to put this technology in its proper box, understand its function, define its function, articulate when we think that function may have loss of function or malfunction, and work with the regulators to find the appropriate mitigations to ensure that it meets the appropriate level of safety. And I think that's the challenge for the regulator, and that's the challenge for the innovator, is to really put AI in its appropriate box. And real quick on the challenge you have with that, I alluded to this earlier. We know that in some cases when we put more autonomy in the hands of humans and we put them on the loop, backing or monitoring that technology or validating that technology, it does not always decrease workload because we think of things like human factors after the design of that system. And at Merlin, one of the things that we're focused on is putting human factors within the design of that system so that as we increase automation, as we take some of those pilot functions away from the pilot or away from the operator, we can think really logically, not just about the physical aspects of human factors, but the cognitive aspects, the attention, the memory, the perception, and how that is changing as you introduce this new technology. So that's one of the challenges, but it's really one of the opportunities that we see.
Definitely, definitely. But yeah, as you said, opportunity does not come without its challenges, and especially when you're on the forefront and you may have that first mover advantage, but you also do all the heavy lifting to get to this place, right? And now you are facing basically two areas that are highly regulated, the aviation industry and AI as such, which will, more or less, how can I say? So regulation on AI part is kind of lacking, and a lot of people are kind of pushing the brakes now to make sure that this thing really does what it should do. But I understood you will, only give it so much authority for a very specific task and maximize on the not just the efficiency, but also on the outcome to make sure that this thing does exactly what it needs to do, right? So
yeah, and I think that's the goal, to make sure the technology does exactly what it says it's going to do, and if it doesn't, that we have some mitigation and design to make up for that. And I think what you're seeing across the world at EASA, at the EU level, at the US level, at FAA, UNESCO, OECD, you're seeing everyone try to zoom in and narrow in on their scope of what AI means to that institution. And I think that's the place we have to be. You can't solve a problem you haven't properly scoped. And so that's the way we think about designing AI for our system, is scoping it well.
wonderful. Bert, do you see any further uses of artificial intelligence in your daily work? I mean, you are more on the not on the end user, but on the side of the users for that technology, not so much on the development side. But do you see things on the horizon that will be interesting or beneficial for your business?
Yeah, I think the biggest thing for us is just growing it and implementing it more. I would say that right now we're probably only using the technology on less than 1% of our infrastructure, and we're only really doing crack detection and spall detection, but we're starting to work on corrosion and there's a whole book of defects that we can identify on a bridge that we use according to the FHWA. So starting to add data sets to learn those other defects, I think is really going to propel it forward. And we're still engineers, we're still the ones making decisions, but as Brendan said, we want it to be kind of a partner for us and help us with our job as opposed to replacing it. I don't think we're not worried about replacing engineers. We have a pretty big workforce shortage that we're trying to address, and this is a really good way that we can do that.
Absolutely, I agree. From a developer point of view, how do you see AI as a unique selling point? I'm pretty sure that with all those recent advances, not just in generative AI, but in general, this advantage might go away over time. And I think my question is, will this soon be ubiquitous, or AI tech as such, or is this still something where others need still a long time to catch up, for example, to systems like Skydio?
So we think the entire industry is on something that we like to call the arc of autonomy, which roughly divides the development of this set of technologies into stages of automation. And we're getting midway through that journey toward this end state in which drones will look probably more like infrastructure than aircraft. They'll be part of your business, they'll be part of your city, they'll perform multiple missions, and they'll work for you. You can task them to do things, but you don't have to do anything other than the tasking and read the 2-sentence report, happy face, frowny face, do you need to be concerned or not, right? That's where this technology is going. The trick is that what people don't tell you about AI is that it's all about talent, right? The heart of Skydio is really our autonomy team. Hundreds of engineers, ton of folks from MIT and Stanford with PhDs who write these algorithms all day long that allow the drone to be smart. So really, human smarts enable AI smarts. That's the secret. And doing that is expensive. It's really challenging. We will see that across the space, again, both on the data capture side and the analytics side, but you have to get the talent right. The one thing that's interesting and important for us is that so many people in this room we see right now integrating drones into their normal ways of doing business in a way that was never before possible. Previously, maybe your aviation unit had 20 to 50 drones. Great, they did specialized workflows with specialized pilots. What we're seeing is those people still have drones. They're doing really high-end stuff. But now your linemen have a drone in the truck, and they're actually throwing it up to know when they need to climb a tower, which tower, and exactly where to look on that tower to find the fault that they're worried about. That's the difference that AI makes. It's all about making something that's so easy to use, almost anyone can use it, in a way that enables you to integrate these solutions into your business rather than have bespoke, specialized kit that sits on a shelf.
All right, wonderful. Travis, quick final question. We have the FAA in the room, and you got basically asked to say what you need. What would you have definitely most touching points in this group with FAA currently? What are the things that you wish for? If you had a magic wand, what would you wish for from a regulatory point of view, from the regulatory side, that will help your business to go forward?
Yeah, this is the hard question. Like, embarrass the regulator in front of industry. No, just kidding. I've long appreciated kind of the hard work of the FAA, and they really have a hard challenge of kind of balancing a lot of things. And I think my wish is that just for all of government to consider how regulation can enable an industry or disable an industry in some respects. I think I heard a joke that the fastest way to become a millionaire in an industry is to be a billionaire first in the UAS space. And it's funny, but it's sad. And I don't point fingers at anyone being responsible for that, but it's super important. I think we see this across emerging technologies. As I mentioned, Hollywood, here in Vegas, and in energy space, in the self-driving car space, that if we do this the right way, we can really enable an economy. And as to Lisa's points earlier, we can enable kind of American competitiveness. Right. So if I had one wish, it would be that we really, really consider our ability to enable regulations and policies to really spur an industry that can have a lot of impact and be safe, because I suspect most people in this room want to continue that kind of long tradition of safety. So that would be my wish, and that's not a wish to the FAA, that's a wish for all of US government.
Wonderful. And that are the perfect closing words for this panel. Thank you so much for being here. Thank you for your contribution to this.